E, starting from this part, I like to give you a sequence of example questions, mainly about problem solving. So it's not about concept questions. So we did a lot of concept questions in quizzes, homework, assignment 1. But for our 2 tests, midterm test and the final 2 tests, we need to solve a lot of computation questions. Problem solving type questions, not concept theoretical questions. All right. So the first E.1 part, I want to give you 3 questions. So each part, each video, we will see 3 or 4 questions. All right, so let's look at the first question. In order to solve the Tower of Hanoi problem for 64 disks, we need to move the disks 2 to the 64th minus 1 times, based on our formula. All right. Now we want to estimate this number. We know this number is really big, right? But here, in the given 4 options, which one is the closest to this number? But these 4 options all base 10 numbers. Base 10 numbers. So we need to do the conversion. The base 10 number and the base 2 number, is there some convenient conversion between them? Yes, this question we need to work on that. All right. First, we will use a simple fact. So if all of you know this one, do you know this 2 to the 10th power equals 1024 approximately equal to 10 cubed? Do you know this? If you know this, simple fact, now let us try to estimate. 2 to the 64th power minus 1. All right. First, let's look at 2 to the 64. Because minus 1 very close to this power of 2, right? Only 1 difference. We can ignore that, right? All right. Equals 2 to the 4th times 2 to the 60th. How about that? The reason we write this way because we have this multiple of 10 number. All right, so then 2 to the 4th, that's 16, right? Times 2 to the 10th to the 6th. All right, Next, let's write it this way. Approximately, because this time we like to replace 2 to the 10th to 10 cubed. How about that? All right, how about that? All right, so then that equals 16 times 10 to the 18th. How about that? All right. Then another step, 1.6 times 10 to the 19th. All right. So that's our estimate conversion. All right. So now, which of the following closest? You can see C is the closest, right? Because C is 1 times 10 to the 19th. 1.6 times. But for others, the difference is much, much bigger, right? For other options, the difference is much, much bigger. Yeah. So we know C is the closest. Yeah. Can you do conversion like that? All right, so that's the first question. Second one, which of the following growth function has the lowest order of growth? All right, yeah. So let us try to simplify. Before we do comparison, let's do simplification. Yeah. All right, so this part, n to the 1/2. All right, so then we need to multiply log of n. All right. Then this part, the numerator, denominator, can we only look at the leading terms? Numerator, we just use the leading term. Denominator, we also use the leading term. So this one, we can simplify to n. N. All right. But we need the lowest order of growth. Lowest, not the highest. All right. So then, look at this one. Pretty low, right? 0.0001. Yeah. All right, so the last one, log of n. Okay, yeah. So here you can see, here the exponent of n, it's 1. Exponent of n at least 1/2, and we have an extra operand, log of n. Yeah. So you can see B is lower than C and D. B is lower than C and D. All right. So the last step, we only need to compare A and B, which one has lower order of growth. Which one has lower order of growth? Yeah. Now, based on my experience, many students, when they answer this question, many of them, they tend to use their intuition here. Yes, here. Intuition here. All right, so think about if you try to use your intuition to solve, because if you use your intuition, you will see this exponent number is so small. That will give you an impression. That will give you an impression. It looks like this expression is very, very small, right? That will give you that impression. Yeah. So for that reason, many students pick option B. Actually, the answer is A. A has lower order of growth than B. Why is that? It's simple. Yeah. Because B, although the exponent number is very, very small, can we still write it as n to the dth power with d positive? Can we still write in that way, right? Yeah, d positive. That 0.0001, that is still a positive number. All right? Then, remember, we did one question using L'Hopital's rule. We did one limit question, log of n over n to the d. By L'Hopital's rule, its limit is 0. Its limit is 0. All right? Yeah. So that means the numerator has lower order of growth than that of the denominator. Lower order of growth than the denominator power function. Yeah. Okay, all right, yeah. So here you can see after this question, yeah, sometimes if you just make your decision based on intuition, many times you can get a wrong answer. Yeah, I remember one student asked me this question before. That student trying to use computer to estimate the value. You cannot. Yeah, because this expression so small. When you use computer, the computer has some limit, right? Has some limit. So it is very hard to use calculation values from your computer to do the comparison on questions like this. Yeah. So do not use computer to experiment for this kind of questions. Yeah. All right. Yeah. So yeah, this one is important. Yeah. All right. Next question. Which of the following expression is always an integer for any positive integer n? Yeah. Here, phi is the golden ratio. We learned that, right? Pi, the ratio of circle's circumference to its diameter. Ratio, yeah. So we know the rate, right? The circular, rate. E, natural log base. Yeah. Yeah. Then these expressions A, B, C. If someone does not have the basic knowledge as we learned in the Fibonacci numbers, then they may not get an idea, how to answer this question, right? Although they can plug in numbers to do the calculation. Yeah, they can try that. Yeah, but we know based on our Fibonacci numbers formula, is this expression just the f of n? Fibonacci number f of n, right? Yes. So then you can easily select that B is the correct answer. Fibonacci numbers, they're all integers. Yeah. But for others, although you replace, you can see for other two formulas, you just replace golden ratio by pi and E. Definitely, they won't give you integers. Yeah. If you want to be safe, you can plug in 1 in each of A and C, just 1. Yeah. Not too hard to calculate. So you will see there won't be any integer. Yeah. All right, so that is the question number 3. So we finish our part E.1 here.